Okay, everyone, last but not least, we're going to take a look at this idea of average rate of change. So another word for average rate of change is slope. And specifically, we're looking at the slope or the average rate of change between 2 points. So our first point we're going to call x1, comma y1, and our second point we're going to call x2, comma y2. Now, in order to find average rate of change, which we abbreviate AROC, average rate of change, is we're going to take y2 minus y1 over x2 minus x1. Some teachers in the past, I'm sure you've seen, as delta y over delta x, which is the change in y over the change in x. Number 4. So the table and graph show the populations of 2 species of fish introduced into a lake. Compare the populations by calculating and interpreting the average rate of change from year 0 to year 4. So species A, we're given a table, and we have to calculate our average rate of change from year 0 to year 4. So I'm going to come over to my table. I'm going to find year 0. I'm going to find year 4. And I'm going to find my average rate of change. So we're going to take the change in y, which is over here, over the change in x, which is over there. So 428 minus 100 over 4 minus 0. So 428 minus 100 is 328 over 4. I'm going to grab my calculator. So 328 divided by 4 is 82. And then because this is a story problem, let's put some meaning to it. 82 fish per year. Now, another thing to keep in mind here is if that's a positive 82, does that mean that the fish population is increasing or decreasing? And in this case, it would be increasing by 82 fish per year. Now, species B. This time we're given a graph, a little bit harder. Year 0, years are down here, so year 0, we're about right here. So I'm thinking that's at about 0, 100. Year 4, up here, so I'm thinking 4, 300. And then we can do the same thing. So we can take y2 minus y1 over x2 minus x1, which is going to give us 200 over 4, which is going to give us, I believe, 50. Yep. Fish per year. Now, they said that we're supposed to compare the populations by calculating and interpreting the average rates of change. So in order to answer this question, I'm going to go with something like this. From year 0 to year 4, species A is increasing at a faster rate than species B. Okay, now, a couple things. Make sure that you specify from year 0 to year 4, because it might not always be true that species A is increasing at a faster rate than species B. What if we were going from year 4 to year 6? Would this still be true? So make sure you specify which years you're talking about. Make sure you tell me whether it's increasing or decreasing. Both of these are increasing. Okay, and then make sure you're using something about our average rate of change. So faster rate, slower rate, something like that. In order to receive full credit, I would need to see this number. I would need to see this number, and I would need to see this interpretation. Example 5. Let x represent the number of years since 1900. The function c of x equals 12x squared plus 12x plus 100 represents the population of Cedar Ridge. In 1900, Pine Valley had a population of 50 people. Pine Valley's population increased by 9% each year. Letter A. From 1900 to 1950, which town's population had a greater average rate of change? Okay, so the first thing I'm going to do is I'm going to kind of split my board. And I know that I'm working with my two towns, and I'm going to make this my Cedar Ridge. And I'm going to make this my Pine Valley. Now I'm going to start with what I know about Cedar Ridge. And I know Cedar Ridge has a function, c of x equals 12x squared plus 12x plus 100. Now, on the last example, we were finding average rate of change, and we found it from a table, and we found it from a graph. Now we have to find it from a function. And in my function, I know that x represents the number of years since 1900, and I want to know from 1900 to 1950. So, if I'm starting in 1900 and I'm dealing with the years since 1900, well, 1900 to 1900, x equals 0. But then 1950 is how many years since 1900, x equals 50. And I have to figure out 2 points. So these are two x values. I'm going from 0 to 50, but what is the actual population in the town at these times? So in order to do that, we're going to use substitution. So I'm going to take my function c of x, and I'm going to first start with c of 0. So we're going to have 12 times 0 squared plus 12 times 0 plus 100. If you figure that out, 0 squared is 0, 12 times 0 is 0, we've got 100, which means my population in Cedar Ridge in 1900 was 100 people. So the point we're dealing with here is 0, 100. Now we have to do the same thing but with 50 people. So C of 50 is 12 times 50 squared plus 12 times 50 plus 100. I'm going to grab my calculator. 12 times 50 squared plus 12 times 50 plus 100 is 30,700. Which means the point we're dealing with here is at year 50, we had 30,700 people in that town. Now, in order to find the average rate of change, we're going to check the change in y. So 30,700 minus 100 over the change in x, which was 50 years, so 50 minus 0. Okay, so that's going to give me 30,600 divided by 50. So 30,600 divided by 50 is 612 people per year. And again, that's a positive number, so I know that the population in Cedar Ridge from 1900 to 1950 is increasing by approximately 612 people per year. Sometimes a little more, sometimes a little less, but approximately that's what's going on. Now, we have to do the same thing for Pine Valley. But what's the issue with Pine Valley? And the issue is they didn't give you an equation. They didn't give you a function. They just told you that the population is starting at 50 and increasing by 9% each year. Well, the first thing I'm looking at is if it increases by 9% each year, that means that it's an exponential function. If it's an exponential function, I know that it's y equals a times b to the x. I also know that a is the y-intercept, or the initial population, which they told me was 50 people. And then the only other thing I got to fill in here is my common ratio. Well, they told me that it's increasing by 9% each year. So 9%, if we remember, means that we can write that as 0.09. But we need to think about this for a minute. If I take my initial population of 50 people and I multiply it by 0.09, that's going to get me 4.5 people. Is 4.5 an increase from 50? And the answer is no. So really, if you take your 50 people and you multiply by 0.09, it gives you 4.5, but that's the increase. So you have to add the 4.5 people back onto the 50. Well, that's too many steps. What do we actually have to put in the equation to get that increase? And the answer is 1. Okay, if you don't remember that, ask me when you come to class, ask your teacher, ask whoever you're dealing with. But in order to get an increase in a function, you have to put a 1 in front of your decimal version of your percentage. So that is the equation that's going to model Pine Valley. Now we have to figure that out from x equals 0 to x equals 50, because we're going from 1900 to 1950. Well, the first one at year 0 isn't so hard, because they told you that the initial population was 50 people. So in 1900, we had 50 people, which means really the only one we have to figure out is at year 1950. And in order to do that, I'm going to substitute it into my function. So y equals 50 times 1.09 to the power of 50, because now it's 1950 and it's 50 years later. So 50 times 1.09 to the power of 50. And I'm getting 3717.87. Now we're dealing with people here. We could keep some decimals on here, but for the sake of what we're doing, I'm not going to have 0.87 of a person. So this comes down to your teacher's preference. If we round normally, we would have 3,718 people. If we truncate it, meaning just cut off the decimal, then we would just have 3,717 people. It's kind of the preference of your teacher and who you're dealing with. I personally could go either way. So if you put 3,718 over here, or if you put 3,717 over here, I wouldn't argue with you. So average rate of change. Change in y, 3,718 minus 50 over 50 minus 0. I'm going to use my calculator. 3,718 minus 50 and then divided by 50 is going to give me 73.36. And again, we're not going to have 0.36 of a person, but people per year. And then ultimately, let's see what it actually wanted us to do. From 1900 to 1950, which town's population had a greater average rate of change? That would be Cedar Ridge. Sorry, my pen is writing funny. So Cedar Ridge's average rate of change was 612 people per year versus Pine Valley was only 73.36. Letter B. Which town will eventually have a greater population? Explain. What we need to know here is we need to know the difference between Cedar Ridge, which is quadratic, and Pine Valley, which is exponential. We discussed this early on in the lesson, that eventually exponential is going to outgrow any other graph. Exponential has a power, so it's 5 to the power of 2, 5 to the power of 3, 5 to the power of 100. That power in an exponential graph keeps getting bigger and bigger and bigger. So eventually a quadratic is going to increase a little bit faster, a little bit faster, a little bit faster. But an exponential gets faster and shoots off like a rocket, almost straight up in the air. So which town will eventually have a greater population? Your answer here is going to be Pine Valley. Okay, and your reasoning is because it's its exponential growth, and an exponential function eventually exceeds the rate of change of all other functions.